Hi everyone, it's Mr. Baker here with another physics video. Today we're going to be looking at efficiency. Okay, so today we're going to be looking at efficiency and we're going to answer this question at the end. What does energy efficient mean? So what is energy efficiency all about? So we've got a couple of pictures here of a filament light bulb and an energy efficient light bulb. But what do we mean by that? So efficiency is a measure of how good a device is at changing energy from one form to another. All devices waste energy, so the efficiency of a device is never 100%. The more efficient a device is, the less energy is wasted. An energy efficient light bulb is more efficient than a filament bulb because it wastes less energy. It converts a greater proportion of the energy that it is supplied with into light energy and not heat. So if you think about it, I get a light bulb to light up my room. Now, filament light bulbs waste a lot of their energy as heat, but that's not the type of energy that I want. I don't buy a light bulb so I can heat up my room. I buy a light bulb so I can light up my room. So the less energy that's coming out as heat as possible, and the more energy that's coming out as light means that it's more energy efficient. And that's what an energy efficient light bulb does. Most of the energy that comes out of it is light. How is energy efficiency calculated? So we can use an equation, and we use this equation. Energy efficiency is the useful output energy divided by the total input energy. We measure energy in joules, so both of those are in joules, and because we're having joules divided by joules, energy divided by energy, efficiency doesn't have a unit, it's just a ratio. So it's just a number between 0 and 1. So you can write it as a decimal, like 0.1 or 1 or whatever. But you can also write it as a percentage. So if you got your answer is 0.5, then 0.5 would be the same as 50%. But you wouldn't write that as 0.5%. You'd just leave it as 0.5. That would be an answer. And if you wanted to write it as a percentage, you'd write it as 50%. So let's have a look at an example here. Let's have a look at how to calculate the efficiency of a bulb. So this filament bulb is supplied with 100 joules of electrostatic energy, which it radiates usefully as 45 joules of light. So how much energy is wasted? So if you want to have a go at this, you might just want to pause the video. Okay, so how much energy is wasted? 100 joules goes in, 45 comes out. So 55 joules is wasted. And you can see how we've worked it out there. So the wasted is the total, take away the useful, so it's 55 joules. So it's just the difference there. How is it wasted? So have a little think. If you want to pause it and have a little think and write something down, you can do. So how is it wasted? Well, it increases the thermal store in the air around it. And what is the efficiency of the bulb then? If you want to have a go again, pause it. Okay, so what is the efficiency of the bulb? So efficiency equals the useful energy divided by the total input energy. So we've got 45 joules divided by 100. So that would be written as 0.45, and that would be fine as an answer, or 45%. Sometimes you might be asked to write it as a percentage or a decimal, but if you're not, it doesn't matter which way around you do it. Okay, so let's have a look at another example then. Let's have a look at television. So this television converts 2000 joules of electrostatic energy into useful energy at an efficiency of 65%. So a slightly different question. So if you want to have a go at this question, why don't you pause the video there. Right, so I'm going to go through it now. So if you wanted to have a go, you should have paused it already. So let's have a look at A. How is the useful energy transferred? So it's coming in as electrostatic energy. So it's being radiated out, isn't it, as light and sound. We want pictures from our TV and we want sound. So we don't really want heat. And that's going to be the wasted energy that's coming out. It's going to be converting into heat, and so it's going to be transferring the store of energy into the thermal store into the surroundings, and we don't want that. We want it to be radiated as light and sound. And how much useful energy is produced? So we know that it's 65% efficient, and we know that the input energy is 2000 joules. So we use the equation again. Efficiency equals the useful energy divided by the total energy. So if we rearrange that equation, we would get that the useful energy equals the efficiency times the total energy. So 0.65 is the same as 65%. So 0.65 times 2000, which was our input energy, equals 1300 joules. If you had a go at that, I hope you did all right on that one. And that's pretty much the end of this little clip, this little video. So these are the things you should be able to do. You should be able to describe what efficiency means in terms of input energy, useful energy and wasted energy, and you should be able to use the equation to calculate efficiency. And we started at the beginning by asking, what is energy efficient? What does that mean? So let's have a look at that. So an energy efficient device will transfer the majority of its energy usefully and as little as possible of the input energy will be wasted. Okay, so I've been Mr. Baker. This has been all about energy efficiency, and I'll see you next time.